So today we're going to be beginning our fourth chapter in this course, which is entitled Quadratic Functions and Expressions. So if you like to organize your notes based on chapter, this is a title that you could put on some sort of chapter divider. We're going to begin today by talking about functions. So you'll notice here that I've indicated the text section where you can find information about functions if you want to read the text section to gain further clarification on anything that we talk about. That's where you would go and look. So we're going to talk about first something that you would have discussed last year, which is a relation. So in the word relation, I'm hoping you see relationship. And so in a relation, we're looking at some data, and we're looking at maybe two data sets or more that are considered together. So basically we're seeing if there's a relationship potentially between the data. So one way, there are various ways that we can represent that. One of them would be as a set of ordered pairs. So for instance, I might look to see if there's a relationship between 1, 5, 2, 10, and so on, right? And multiple ordered pairs. So in doing so, we would be looking for the relationship between, of course, our x variable and our y variable. All right, so that is, of course, one way we can do that. Another way that we could go about that would be to create a table of values. So by looking at simply, x and y values, we can identify whether there's a relationship there between them, whether they constitute a relation. And lastly, one way that we can represent a relation is, or to compare two sets of data, is to write an equation. And last year you would have seen an equation, a linear equation, which would look like this, so y equals mx plus b. So in doing that, we're really looking at, well, what is the relationship between the variable x and the variable y? How is one changing with respect to the other? And a conversation around what is the dependent and independent variable probably happened. So there we have it. Those are different ways of representing a relation. So down here, I've got three different relations, which I'd like you to take a look at. And we have three different cases. And so we're going to examine some attributes of each of them. So I'm going to tell you that these are all relations, but not all of them are what we call a function. So a function is really just a subsection of relations. It's a special type of relation where for every x value, there's only one y value. And I want to explain that to you because students are often confused about that. For every x value, there is only one y value. And so my question to you is, which of the above relations is also and could be called a function? So pause the video, make your selection, and then we're going to talk about it. Okay, so let's check how you did with this. So when I look at relation A, I'm looking to see, well, for every x value, right, is there only one y value? So for this first x value of 2, I can see here that there's only one y value, and that y value is at 3. And then when I look at each of the coordinates in this relation, I can see that for every single x value, there's only a single y value. However, when I look at the relation B, I can see that there's the case right here where I have a coordinate that is 4 and 3, it looks like, and I have another coordinate that is at 4 and 5. So in this case, I have two coordinates that both have a value, an x value of 4, but they have different values for y. So remember that in our definition for a function, for every x value, there can only be one possible y value, and here I have two different y values. So the last question, some of you may have thought that it wasn't a function because you took a look at, I'm going to say, this coordinate and this coordinate, right? So I'm going to write down what the what the ordered pair is for each of those. For the first one, I have 2, 4. And for the second one, I have 6, 4. Now let's carefully read our definition again. The definition of a function is for every x value, there is only one y value. It doesn't say anything about for every y value, there only being one x value. So here we have the case where we do not have, or we do only have one x value for every y value, and so this is most definitely a function. So there's an even easier trick that I can show you to help you quickly visually determine whether a relation is a function or not. So stay tuned. All right, so a really quick and easy way to identify whether a graph is a function, whether the relation is a function, we're going to use, it's called the vertical line test. So I've got my handy dandy vertical line here, and where I'm going to show you how this test works. So basically, if any vertical line passes through more than one point, I'm going to highlight that, more than one point on the graph, and we're talking about that vertical line, then it is not a function. So for instance, I have intentionally chosen a graph here that is not a function. It's a relation because I'm looking at the relationship between my y coordinates and my x coordinates, but it is not a function. So let me show you how that vertical line test works to show that. So I would take any kind of vertical line. You can use like a ruler or a finger, I don't know, and then you just kind of move it across the function. And I can see that there are multiple points here, multiple points where that line is crossing at 2 different spots on my graph here, right? So given that, it is not a function. So yeah, again, the vertical line test, quick little trick. I've just quickly scanned back to the last examples. So I can see here, if I perform my vertical line test on this relation, I can see that at no point is my vertical line crossing, crossing 2 points at the same time. Whereas I can clearly see that over here where I don't have a function, where my red line is touching 2 points at the same time. Again, moving it over to the last graph again, and if I scan from left to right with my vertical line, I can see that at no point is that vertical line touching 2 coordinates or 2 portions of the graph. So there you have it. So what I'd like you to do before you move on with the video is I'd like you to open your textbook up to page 197, and I'd like you to try out these questions and do a self-check by checking the answer key in the back of the textbook to make sure that you're on the right track. If you don't have your hard copy textbook with you, remember that on my website, which can be found on my Google Classroom, you will find the online textbook, and you should be able to access these questions. If you have trouble with any of that, please get in touch with me and we can come up with an alternate solution. Okay, so today I want to talk to you also about some key terminology that will be utilized in this unit when we talk about quadratic functions and functions in general. In fact, when you move on to grade 11, the first unit you'll have a long conversation about domain and range again. So what do we mean when we say what is the domain and what is the range of this function? So it's actually quite simple. The domain describes all the possible values for the independent variable, in other words, the x values in a given relation. Okay, so domain describes all of the possible values that you can have for the x coordinates in a given relation. So what do you think that the range might be? Well, the range, as you might have suspected, is the term that we use to describe all of the possible values for the y coordinates. So remember, let's think domain describes x, range describes y. So let's look at an example that will help to make that, I think, a little bit more clear. So here what I have is I've represented a relation in terms of ordered pairs. Now remember, I could have identified this in terms of a table of values. I could have represented this as an equation, but in this particular example, I am going to write this out as some sets of ordered pairs. So a couple of things. If I ask you what the domain is, again, that I want you to respond with what the possible x values are. And so here you can see that I've highlighted in red each of the x component of each ordered pair, and I've simply listed them. There's a couple of other features I want you to note. One is that I have these sort of squiggly brackets around. That is the convention that we use in math to describe either the domain or the range. So then what is the range in this case? Well, remember that the range represents the y values. And so all I need to do, it's really simple, all I need to do in this case is to write out my y coordinates in order from lowest to highest. So here we go. Here's my attempt at a squiggly bracket. 2, 5, 9, and 13. And so then close my squiggly bracket. And that is it. Okay, so on this particular graph, I see that my coordinates, I've been giving a series of coordinates. And so I need to be careful here because when I talk about domain and range, there's a difference between the case where I have coordinates that are not connected or not joined by some sort of a line and those that are. When I write out coordinates that are not joined, what I'm telling the reader is that only these coordinates are part of that relationship, not the points that lie in between those. However, if I had joined these coordinates together, then that would imply that all of the little points in between the coordinates that are represented are also part of the domain and the range for that particular relationship. Okay, so in this case, my coordinates are individual. We call that a discrete relation or a discrete function. Discrete means it's not continuous. So what do we call a relation where the dots are connected? We call that a continuous relation. So there are a variety of ways you could kind of work through this. At the end of the day, remember, domain is representing the x component of each coordinate, and the y is representing the y component of each coordinate. So, what I could do is I could go ahead and I could write out what each of these were. So -3 and 4. I've got -1 and 2. I've got 1 and 0, and I've got 2 and 0. If however you want to do that, that's fine. Table of values doesn't really matter. So if I'm talking about my domain, here's a short form that we can do, right? D with that colon there. I'm going to do my squiggly brackets, and I'm going to remember that my D are all my x coordinates, so I'm just going to simply locate all of them here, boom, 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 and then write them out. So that would be -3, -1, 1, and 2. Close squiggly brackets. My range is, of course, going to be 4, 2, 0, and I don't need to repeat that 0. Some textbooks will write your range in the ascending order, 0, 2, and 4, but notice that I did not need to repeat that 0. All right, let's take a look at the next question. So in this case, we have a continuous function rather than a discrete function. And so the way that we approach listing the domain and range is a little bit different. So notice here that I've inserted some arrows at the end of this linear function. And so what those arrows are saying is that, even though the graph really, the scale that can be shown here is only, so big. This function we can understand to continue to go along outside of the sort of parameters of this particular graph. So when describing the domain and range, we need to take that into account. We also need to take into account that although we have some distinct coordinates, all of the, decimal or fractional coordinates in between are also represented in this function. So the way that we describe the domain and range is a little bit different here. So I'm going to say the domain. And so we have to say, well, what does the domain actually, what is it here? Well, I know that based on this function that my x values are going to go up and up and up and up and up forever and ever. And I know that they're going to go down and down and down and down and become increasingly negative on and on and on as well. So in this case, really, all of the x values are part of this function and can be represented by this particular function. So the way that we show that is we would say, well, x, and this is what we would do, x is such that, either a colon, sometimes you'll see a bar. Oops, let me make that a little prettier. This is just the math convention. You can use words. X is such that x belongs to, this big E looking like thing means belongs to the set of real numbers. So notice the R here is like this weird sort of double barred R. So what does that translate to in English? We would say x is such that x belongs to the set of real numbers. So take a minute and write down what you think that the range would be for this particular function. Well, I'm hoping that you thought about it very similarly to how we thought of the domain, and that, we talked about, on and on and on this way, left and right, but also this graph is continuing to go up, 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 and down, 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 right? So, we know the vertical describes our y coordinates. So this graph is going up, 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 and down, 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 on and on and on. So we can also say that our range, shows that y is such that y also belongs to the set of real numbers. And that's it. So I've got one final example that I want to go through with you because just so that you're aware of certain considerations that need to happen. So in this last example, I can see that I have a function. It passes my vertical line test. And so when thinking about my domain and range, I need to think about what are all the possible values for x and for y respectively. So I'm going to start with the domain here. So my domain in this case, it's a continuous function. It's not a discrete function, so I can't just describe individual coordinates. I have to describe all of the values in between those as well. So this is, when I look at this, I'm going to say, all right, well, x is such that I know for sure that all of the values, x is going to keep going on, this graph's going to keep going on and on and on. So, right, and it's going to keep going left, 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 left. So all of the possible values are available for x here. So I'm going to write that out. So x in this case is such that x belongs to the set of real numbers. Basically, this is just saying all of the x values that are there are a possibility for this function. Let's look at range, because the range is a little trickier here, right? So I'm going to look at y and what's happening with y. And although I notice that this graph will keep going up, 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 up in each direction, there is a minimum value here at -1. So in other words, none of the y values below -1 are a part of the range for this function. And so I need to indicate that. So this is what I would do in that case. So I would say, again, y is such that y belongs to the set of real numbers, but I need to add something to this. And so normally I would continue on in the same line, but I'm running out of space. I would say that y, in this case, has to be greater than or equal to -1. And what am I saying here? Well, I'm saying that only the values of y that are -1 or above are a part of the range for this particular function. Okay? So, that is setting a restriction there. So remember, just a couple of points to remind you. If I have this is greater than or equal to, this is less than, and this is less than or equal to. And so we're going to use the greater than symbol when the point is not included. We're going to use right, so for example here, I can see that this graph actually does pass through -1. And so that means that -1 is a part of that range. So I would put greater than or equal to. And so the same goes for the less than or the less than or equal to. Those are things that I want to consider. All right, so now I think we're at the point where you should be ready to start some more practice by working through some other questions in this text section. Here are my other suggested problems that I think you should work through. And again, if you feel like that's not adequate for you and you need extra reassurance or you want to build more confidence, and feel free to do questions above and beyond this, or reach out to me and maybe we can find some extra work for you. And again, as always, if you're struggling with any part of this or need some clarification, be sure to reach out.